Good day. Welcome to the online lecture series of plastic deformation and metal forming. So in this lecture series, we will discuss about the fundamentals of plastic deformation and different metal forming operations. As you know, the plastic deformation is a very important manufacturing process in industries. To make any different types or different varieties of product can be made using plastic deformation process or metal forming process. So here in this lecture series, we will discuss about the fundamentals of plastic deformation and especially different basic forming operations like rolling, forging, extrusion, drawing, and different sheet metal forming operations. And the initial content of this lecture series is the fundamentals of plastic deformation. And in this area, we will discuss about the plastic deformation of metals, and then we will discuss the some what happened to the solid mechanics of solids when we do the plastic deformation. We will discuss the stress strain relationship and the state of stress in during plastic deformation, and we will discuss two yield criteria. These two yield criteria is very important in plastic deformation area, that are Tosca criteria and von Mises criteria. Then we will compare these two criteria. Then we will discuss the flow rules related to the plastic deformation and how much amount of power and energy required for different deformation process, and the heat generation and the temperature involved in the plastic deformation also will be discussed in this lecture. And this is the syllabus of your third module. And in this syllabus, we can divide the syllabus into two parts. The first part, this one, that is related to the 3.1 and 3.2, that is related to the rolling process. And the second part, that is the 3.3 and 3.4, that is related to the plastic deformation of metals. So here in this, the 3.3 and 3.4 gives the fundamentals of plastic deformation. So we will discuss, initially we will discuss this 3.3 and 3.4, where we discuss the basics of plastic deformation. Then after completing this 3.3 and 3.4, then we will discuss about the rolling process. The rolling process is one of the basic or fundamental metal forming process. We will discuss about the rolling process. And coming to the course outcome of this module, at the end of the course, students will be able to estimate the working load for pressing, forging, wire drawing, other process, etc. So at the end of this course, you will get an idea how can we calculate the working load required for different metal forming process. So we will discuss at the end of the course. You will get an idea about this. We will discuss about the working load requirement in this module. And the second course outcome you will get is that you can recommend appropriate part manufacturing process when provide a set of functional requirements and a product development constraints. So at the end of this course, as an engineer, you will get an idea which manufacturing process, which metal forming process is apt or appropriate for for the production of a particular part. So when we convert a raw material into a final product by using a metal forming process, which metal forming process is the most appropriate metal forming process? So you got an ability to select the appropriate manufacturing process or metal forming process for the production of a particular part. That is also the outcome derived from this at the end of this course. Coming to the introduction of the metal forming or plastic deformation area, basically the manufacturing of metal parts and assemblies can be classified in a simpler manner into 5 general areas. So we know around us we have different products which is developed or which is produced in a manufacturing industry. For example, if you take a pen that is developed or manufactured in an industry, if you take a candle, this candle also a product from a manufacturing industry. If you take a mobile phone, this is also a product from a manufacturing industry. So for producing all this type of products, we use different types of manufacturing process, and this manufacturing process makes different parts. Okay, for example, in case of this mobile phone, it has number of parts. Okay, so there is a casing area, there is a screen area, chip area, and there are number of connecting or joining components like screws, and we can see keys. There are different types of components are used to make this mobile phone. So after making the parts, we assemble all the parts to make this complete product. So for making most of the products, we make the parts initially using any of the manufacturing process. Then we combine or we assemble all the parts to produce the final product. Okay, so for making the parts, we use different manufacturing process, and this manufacturing process can be classified into different. The primary classification is the 5 classification. That is, the first one is the primary shaping process. You already studied the primary shaping process like a casting. In case of casting, what we do, we pour the molten material into the die, and the die will have a required shape of the final part. And we discuss different types of casting process. So from the at the end of the casting process, we got a primary shape. Okay, so for example, the final product may be resembled to a rectangular shape. So initially we make a rectangular shape raw material. by primary shaping process. So basically, commonly we use casting process as a primary shaping process. Then after that, what we do, we use the product from the casting or primary shaping process to make the final product or final part. For that, we can use the metal forming operations. There are different types of metal forming operations are there. In this metal forming operation, what we do that, we take the raw material which has a definite shape, and we plastically deform the raw material into the required shape. That is the metal forming operations. And we can classify the metal forming operations like a rolling and extrusion, forging operations, drawing operations, and different types of sheet metal operations are also a part of metal forming operations. So by doing metal forming operations, we can convert the product which is manufactured by the primary shaping process into a final or near net final shape product. Okay. The next process is the metal cutting operations or machining process. Because at the end of the metal forming process, we got a product or a part, but which will have a less surface finish or accuracy, etc. So to improve the surface finish and accuracy, and to cut the remaining unwanted portions, etc., we use different types of metal cutting process like sewing, turning, milling, broaching. So these are the metal cutting operations where we remove the material in the form of chips using a machine tool. So that is the metal cutting process. Then after, at the end of metal cutting process, we got a final product. Final product like a for example, like a scale, we got a final product. Or if it is a material metal part, for example, the door of a car. So that is a final product. At the end of the metal cutting process, we got the final product. Then after that, we do a metal treatment process. That is also an important manufacturing process. What is the requirement of treatment process? In the metallurgy and material science class, you have studied different types of material treatment process like annealing, quenching, normalizing. And there are different types of material treatment process are there, and case hardening. So surface treatments are there. So by doing these treatments, we can enhance the properties of the material. Thereby, the strength and other physical, chemical properties can be improved for that part. So for that, we use different metal treatment process, metal treatment process. And after metal treatment process, then we go for joining process. For example, in case of car, we make the body, we make the door, we make the glass, we make the engine parts. So there are different parts are there. So we combine all the parts, or we join all the parts using different joining process. The joining process are there, different joining process are there, like a welding process. That is the main important joining process. Then we do riveting. We use the temporary joints like a bolt, nut, etc. So we use different joining process. And out of these 5 different manufacturing process, the metal forming process is a very important manufacturing process, because in most of the industries, for mass production of the components or parts, the metal forming process is used. So that is why we are very concentrated in this area, metal forming process. So let's see an example here. This is a continuous casting process. Continuous casting process. So you already studied continuous casting process. In case of continuous casting process, we pour the molten material using the ladle into the tun dish, and from the tun dish, when we open the tun dish from the bottom, these molten material flow into the copper mold. Okay, so the copper mold gives a cross section of the final cast product, and this copper mold, we allow this molten material to solidify in the copper mold. Then using some rollers, we take out the final product from the continuous casting setup. Okay, so finally we got a continuous casting raw material with a rectangular shape and a very higher length. Okay, so this is a continuous casting process. We already discussed this, and this is a primary shaping process. Primary shaping process. This continuous casting or any casting process is a primary shaping process. So we got this type of raw material at the end of the casting process. And what we do this using this raw material, we use this raw material for next process, like a metal forming process. See this raw material here. In this case, this is a square cross section. So we can say this square cross section as a billet or blue. Okay, so this is the product we got from the casting process. And similarly, we can make a rectangular cross section like a slab, and we can make a bloom type higher cross section. Here, for billet, the cross section area will be very small, but for bloom, the cross section area will be large, and we can make a slab also. So this type of raw materials or ingots, we can call this as ingots, can made using the primary casting process or primary shaping process. Then what we do using this slab, billet, bloom, etc., we do different metal forming operations to produce a particular near net shape components. Here we can see this bloom. See this blue. In this blue is passing through this type of set of rollers. We arrange a set of rollers, and when this bloom passing through the set of rollers, we got a cross section, structural cross sections. Let's see this. This is an I section. Okay, I sections. This is structural member. Okay, so we got different structural members as an output from this forming process. This is a forming process. This is a rolling process, a type of rolling process. So we got a final structural member from this blue. Bloom is the ingot or raw material here, and using this bloom we can convert into this type of structural members using a forming operation. See this billets, using the billets we can make, see this tube, round tube we can make a round rods. So here actually the cross section is rectangular, but you when it pass through this rollers it can convert into rods, bars, and again we do another process. This rods is converted to very small diameter wire by using a drawing operations. This is a drawing operation. That is the metal forming operation. And here the seamless pipes is made using a rolling operation. See this actually this is not hollow. The tube round is not hollow, but when it passing through this rollers, we got a hollow pipe, seamless pipes. So we can make a pipe using these metal forming operations. And so this is the drawing operation. So we can make different components like this. And another one is the using slab also we can make using this casting process. And using slab we can make thin steel plates can be made. We can make welded pipes using this type of this is also a forming operation. This is also a forming operation. So we can do different forming operations on the ingots to make different products. So that is the conclusion of this process. So this is a crankshaft. So we can see this is a very complex shape component used in automobiles. How this crankshaft is made. So for making this crankshaft, we can do different process. So we have to do different process on this raw material to make a crankshaft. See, let's see what are the different process. Initially, we have a raw material. We pour the raw material, and this is a continuous casting process. At the end of the continuous casting process, we got an ingot. Okay, a bloom type of ingot we got from the continuous casting process. Next we will see what is the next process. See this one is the final product from a continuous casting. This one is the final product from continuous casting.
The linked production of passenger car crankshafts also starts with billets, induction heated.
So this is a billet. This is the billet is coming from the continuous casting process.
To forging temperature. The corner.
See this is a pressing operation. This is a metal forming operations, especially the pressing process. And we have two dies, and in between the die we kept the billet, which is coming from the continuous casting process. Then we press the billet. Okay, so by pressing the billet,
are flattened and the surface is descaled. The pre and finish forging of a 5-cylinder crankshaft is performed in.
See this press has a particular cavity here, and when we press in between the dies of the press, what happens? The billet is changes to corresponding to that shape.
Plain dies. Afterwards, the workpiece is clipped. The flash goes to the strap bin, while the crankshaft is transported to the next station.
See this, at the end of the pressing operations, we got an approximate shape or nearness shape of the crankshaft.
A twister, an operation in which 5 strokes of the shaft are properly aligned relative to one another by twisting. The final operation in the production of crankshafts is hot sizing. During this process, the crankshaft receives its required accuracy in form and dimension.
This is the final process on the crankshaft, the final pressing process. We got nearness shape for the crankshaft at the end of this is a finishing process of the pressing.
The dimensions are automatically tested and documented in accordance with the sampling plan by a...
See this is the end product. So initially the first process was continuous casting. From that we got billets, and using that billet, using different pressing or metal forming operations, we got the crankshaft. So this first video is the metal forming operation. So next we will see what is the next
coordinate measuring machine.
Next we will see so this is metal forming operation. Metal forming. This is the metal forming. This is the casting process. This is the primary shaping process. This is the metal forming operation. So next we will see the next process. This is the machining operation. So in this machining operation, So after, this is the machining operation. The machining process is used to create improve the surface finish of the component and also the improve the accuracy, because at the end of the pressing process or the metal forming process, the accuracy may not be exact. So in order to get the exact accuracy and to remove the unwanted parts from the trim the unwanted parts after the pressing process, we do machining process. So this is the next process, machining. Okay, then after machining, then we go for heat treatment process. This is a heat treatment process. Here we can see this part is heated to very red hot condition. Then after that, see this. See this. So we heated to very hot condition, red hot condition. Then we apply water into the water. So we dip inside the inside water for quenching operation. So it's a heat treatment process. So we this is the next operation after machining. We do heat treatment process. Okay. So after heat treatment, there is one more process, that is the joining process. So this is the sequence of process for most of the materials. First we do some primary shaping process like casting, then we do metal forming process, then we do machining, then heat treatment process, then finally we go for assembly operation. So out of this, we are concentrating on the metal forming operations. What is the main importance of the metal forming operations? The metal forming is the backbone of modern manufacturing industry, besides their being a major industry in itself. So this is a very huge industry nowadays for producing different products. Okay, so we can see the importance. Around 15 to 20% of the GDP of the industrialized nations are come from forming industry. See the importance. Around 15 to 20% of the products or total GDP is coming from the metal forming industry. So that is the importance of the metal forming. We make most of the products using metal forming operations. There are different advantages of metal forming operations compared to other manufacturing operations to produce the particular product. We can make a particular product using different operations. For example, in case of the crankshaft, we don't need any type of metal forming operations for making crankshaft. We can do machining itself. Okay, complete machining. We can convert the raw material into a crankshaft using machining only. Okay, that is possible. But if you make a crankshaft using machining operation only, then the cost of making is very huge. Okay, so for a particular company, they are going to make 10,000 crankshaft. This machining is not a best option. In that case, we go for metal forming operations, because using metal forming operations, we can make the part very easily with a high productivity. That is the advantage of metal forming operations. That is why in most of the industries focus on metal forming operations. And in metal forming process, the product shapes are produced by plastic deformation. So we will discuss about the plastic deformation in detail. So metal forming includes large group of manufacturing process in which plastic deformation is used to change the shape from the metal workpiece. So last video we saw that this is the raw material, and this raw material is converted to, see this rectangular cross section raw material is converted to final product like this. This is the final product. Okay, so using these metal forming operations, we can convert the raw material into a near net shape product. Okay, the deformation from the use of tool, usually die in metal forming, which applies stress that exceed the yield strength of the material. So that is very important. How much amount of stress has to apply for deformation of the material? When we press a particular raw material in between the die, how much amount of load has to apply, or how much amount of energy has to supply, or how much amount of stress has to supply is an important factor in metal forming. We will discuss the fundamentals of that later. So see this, these are the different components used in the automobile, and most of the components are made using these metal forming operations. See this is the connecting rod. This one is the connecting rod used. So this connecting rod can be easily made using a set of metal forming operations. So these are the importance of the metal forming operation. All the materials are made using metal forming process. So next is metal forming or plastic deformation of metal. So among all the manufacturing process, metal forming technology has a special place because it helps to produce parts of superior mechanical properties with a minimum wastage of material. So these are the two very important properties of the or characteristics of a metal forming process. That is, it has a good mechanical property. The final product will have a good mechanical property compared to any other manufacturing process. Second one is the minimum waste of material. The material wastage will be minimum. See this, for example, in the previous case, if you make this crankshaft using machining process, what we do, we have a for example, if we use a machining operation, this will be the cross section of the this will be the front view of the raw material requirement. So then we do some machining. So we do machining here. So we remove the material from this portion. Then we do machining here. So we remove the material from all this portion. Okay. So by removing the material only we can do machining, and we can convert the raw material into final product. So there will be a huge material loss in case of machining process. Okay. But if you do metal forming process, what we do, we convert the raw material into final product. We find a product without any wastage of material. We are not removing any material from the raw material to produce a final product. We just deform the raw material to get the final product. So that is the main important advantage of metal forming process. The wastage of material in the metal forming process is very minimum. And second one is that in metal forming process, we do this compressive. We apply the compressive force in the metal forming process. Say we have a die. So this is top die, and this is my bottom die. Okay, and this is my raw material. This one is my raw material. And using this raw material, this is my raw material, and we apply the compressive force using the die into the raw material. So this material is plastically deformed under compression. Okay, under compressive force. So this will enhance the property. The you may studied about the dislocation density, the number of or the total length of dislocation per length or per volume. That is, dislocation density can be improved. So when the dislocation density increased, then the strength and other properties also will be improved. So thereby, this metal forming process improve the mechanical properties of the material. That is, these are the two important characteristics of the metal forming process. In metal forming process, the starting material has relatively simple geometry. It may be a rectangular geometry, it may be a round geometry. So the material is plastically deformed. This is very important. We should consider this term plastically deformed. For any metal forming process, we should deform the material plastically. There are two types of deformation. That first one is the elastic deformation. Second one is the plastic deformation. When we do any elastic deformation, for example, consider this raw material. So when I do elastic deformation, that means I applied a stress within elastic limit. Within elastic limit, when I release the load, what happened? The material come back to its initial state. Okay, so there will not be any permanent deformation on this material when I apply a stress which is within elastic limit. But when I apply a stress which is greater than the yield strength of the material, what happened? After release of the load, there will not be any recovery. Okay, this is the plastic deformation. Okay, so this is a permanent deformation. There is no recovery of the raw material or into initial shape. It will not regain its shape into original shape. Okay, so that is, we have to apply the deformation plastically. So the material is plastically deformed in one or more operations. Maybe in metal forming process is not a single process. We have to do number of process for making a particular component. There are different processes are there. Okay, so we do one or more operations into a product which has relatively complex configuration. Okay, so forming to near net or net shape dimensions drastically reduce the metal removal requirement, resulting in significant material and energy saving. I already explained, in machining process we have to remove material from the raw material to get the final product. But in case of metal forming operations, we don't need to remove material. We just need to deform the raw material to get the final product. So we can save energy as well as material using these metal forming operations. Metal forming usually require relatively expensive tool. This is one of the major disadvantage of the metal forming operations compared to any machining operations or any other manufacturing operations. The metal forming require comparatively expensive toolings, and the dies, pressing equipments, etc. The cost of these toolings are very high. So for making a very low number of quantity, okay, if it is not a mass production, the best manufacturing process may be machining. Okay, for example, in a particular industry, they need to make 5 components only. Okay, only 5 components are required. Then they can use machining operations, because using machining operations, we can make these 5 components with a relatively low cost. But for a manufacturing industry which has to make a 10,000 components, a mass production, 10,000 components, in that case, this machining is not a feasible one. In that case, we have to purchase these high expensive toolings for this metal forming operations. Then they can do the mass production of the components. So when the number of components is increased, the total equipment cost is divided into each component or each component. Okay, so the cost per component will be less in case of metal forming of mass production. But if the number of components are very low, the purchase of the high expensive tooling will be not a good or it's not a recommended one. Okay, so that is a very important. Relatively expensive toolings has to be used. Thus, the process is economically attractive only when the large number of or mass production of parts must be produced. Okay, if a particular company making a parts in a large number, then only this metal forming is a feasible option for the production. And when the mechanical properties required in the finished operations can be obtained only by forming operations. For example, in case of aerospace components, or in case of nuclear reactor components, or in case of very special components has to manufacture with a very good mechanical property, then the choice is only metal forming operation. Okay, so in that case, the cost is not a factor. The quality or the mechanical property or the material property of the material is the important factor. Then we can go with the metal forming operation. So, why metal forming? Metal forming, there are different manufacturing processes are there. Why we choose metal forming operations? The first one is the high production rate. I already explained in case of crankshaft. If you machine a crankshaft, maybe a particular crankshaft has to take 1 day full for the machining. But within 5 minutes or within 10 minutes, we can make a crankshaft using a metal forming operation. So that is the difference. Okay. So high production rate is the one of the important advantage of metal forming. Improve the mechanical property. I already discussed when we apply the compressive force, the dislocation density may increase. Okay, it will increase the mechanical property also. So the different mechanical properties can be improved using this forming operations. Reduce the internal defects. So this is the use of compressive force for changing or for the plastic deformation. So the internal defects or the density of the internal defects can be reduced by using metal forming. Then compressive residual stress is developed. So initially we apply the compressive force for the deformation. So when we apply the compressive force, in the material, compressive residual stress will be developed, and this compressive residual stress will nullify any tensile stress developed on the material. So this is an added advantage of metal forming process. So this compressive residual stress improve the especially the fatigue strength and creep strength of the material can be improved by using this compressive residual stress that also developed in the metal forming operation. It's very easily for automation. We can use different machineries with the automatic arrangement for mass production of the components. Close control over the properties. Okay, we know how much amount of load is applied. We know the different parameters we use for these forming operations. So next important advantage is the high strength to weight ratio. So compared to another the compressive force is applied in this process, so the strength to weight ratio will be high in case of this metal forming operations. This is because this high strength is because of this improvement of the mechanical properties. And these are the main advantages of metal forming process. But there are different disadvantages for the metal forming operations. First one is the anisotropy of the structure produced. That is a disadvantage of metal forming. For example, in case of rolling, this is a rolling process. In between the rollers, we pass the raw material. So this is the here raw material has this much of thickness. After rolling process, the thickness is reduced to lower value. This is the rolling process. Okay, so in this rolling process, actually the compressive stress is applied in this direction. Okay, so in this direction the material is compressed. In this direction the material is compressed. Okay, and in the length direction the material is elongated. Okay, and so in one direction the material compression takes place, in one direction material elongation takes place. So there is a chance for this anisotropic behavior, okay, of the material. So this anisotropic behavior may in some applications this anisotropic behavior of the material is a added advantage, but in some case this is a problem for final product. And this metal forming process is limited to simple shape. Very complex shape cannot be machined using these metal forming operations. If the shape is very complex, then we have to go for high energy machines like laser machining or electron beam machining, etc. Or we can do different EDM, electron discharge machining, etc. So this is only useful for the simple shape. These machines to achieve required finish and tolerance. So that is important. After metal forming operations, we need to do some machining to improve the surface finish and accuracy of the final product. And difficult to control of process parameters. Okay, the process parameter controlling, because in machining process, feed, depth of cutter, the speed, and the tool signature. So different parameters are there. So we can easily control all these parameters even in the automatic setup. But in this metal forming, there are some difficulties for the controlling of the parameters. Mechanical properties, namely yield strength, ductility, affects success of the process. That is very important. For example, we have a particular product, and then we do some forming operations. So what happened at the end of the forming operations, the strength and strength is increased and then ductility may be decreased. Okay, so this strength improvement and ductility decrease may cause next process. Maybe in the next process may be another forming operations or maybe a machining operations. So this next success process may affect because of the high strength and high ductility. So we have to do some heat treatment process after the forming process to reduce the strength and ductility. Then only we can do the next process. Otherwise, the next process will be very difficult to carry out. Okay, so that is very important. The mechanical property may affect the yield strength and ductility. So these are the main advantage and disadvantage of the forming process. And basically, the forming process can be classified into two. That is massive or bulk deformation process, like a forging, rolling, and a drawing. And the next forming process is a sheet metal forming process, like a deep drawing, stretching, punching, blanking, etc. So this is actually the two categories or two classification of the metal forming process. So we will discuss this rolling process in your third module, and forging process, drawing process, etc. in your fourth module. And in our fifth module is will cover the sheet metal forming operations, different sheet metal forming operations. So we will see. Okay, these are the two classifications. The forming process are especially attractive in cases where the part geometry is of moderate complexity. So relatively simple shape is more appropriate for metal forming operations, and the production volumes are very large because already we discussed the expense or the cost for the toolings of the metal forming operations is very huge. So for an industry with the production of large number of volume parts, this metal forming is an appropriate manufacturing process. And that, for example, automobile industry. In case of automobile industry, most of the components parts are made with the metal forming operations, because where industry make mass number of products. Okay, so so that they can purchase toolings for the metal forming, and relatively simple shapes are developed in the automobile industry. The parts properties and metallurgical integrity are extremely important. So where also we use the metal forming operations like aircraft, jet engine parts, turbine components, reactor components, etc. Where the mechanical property, the property of the parts and the metallurgical integrity. I already explained the metallurgical properties of the material after metal forming process will improve. Okay, so this will enhance the property of the components used in this area. This is a very high-end engineering applications area, so where we can commonly use metal forming operations for the production of parts. See an example here. We have a threaded bolt. Okay, and this threaded bolt can made with two process. One process is the machining process. This is the machining process. Okay, so using lathe, conventional lathe, we can make a this bolt, threaded bolt. Okay, what we do, we place the blank between the centers of the lathe, then we force the tool against the workpiece, and we remove the material in the form of chips in the machining operations. So at the end we got a threaded bolt from the machining. So this is the one process for making the threaded bolt. Another process is this one. This one is the next process. In this process, this is the rolling process, the metal forming operation. This is the machining operation. This one is the machining operation. This one is the metal forming operations, rolling process. Okay, what we do here, we have two dies with the similar grooves of this thread. Okay, similar grooves of this thread. So this is the first roller and this is the second roller, and we get the workpiece in between the two rollers, and we force the two rollers against the workpiece to produce the threaded area on the workpiece. Okay, so we deform the workpiece into a threaded like structure by the application of the compressive force in rolling operation. Okay, so we can make a threaded part using these metal forming operations as well as using these machining operations. Okay, so what are the advantages? If you use a machining operations, for example, for an industry, they want 10 bolt, they need only 10 bolt, metal threaded bolt. Okay, then they can go with the machining operations, because the production of 10 bolt using a lathe machine is very easy. Okay, so they can go with the machining operation. But for an industry, they want a 10,000 bolt. So the production of 10,000 bolt with the 10,000 bolt with the machining operation is very difficult. Okay, it's very difficult. So they can purchase the toolings for metal forming operations. They can make the 10,000 bolt very easily using a metal forming operations. Okay, so this is the first advantage. And see the microstructure. This is the microstructure after machining, the thread microstructure. So this is the threaded area, and this threaded area microstructure is shown here. This is the microstructure after the thread machining process, and this is the microstructure after rolling process. Okay, see this here, the grains are cut here. This is not a continuous grain. At this edge the grains are cut. But here we can see these grains are not cut. Grains actually flowing here like this. It is flowing like this. This is not a discontinuous grain, it's a continuous grains. Okay, so the grain flow lines in machined and rolled threads, unlike machined thread which are cut through the grains of the metal, rolled threads follow the grains and are stronger because of the cold working involved. So here this type of grain structure will be stronger than that of this type of grain structure, or we can say the threaded bolt made with the rolling process has higher strength than that of the threaded bolt made with the machining operation. The classification of metal forming operation, I already explained. There are two classifications. That is, first one is the massive or bulk deformation process, and second one is the sheet metal forming process. And this is an example of rolling process. This is a bulk deformation process. Here we can see the size of the raw material. It's a very bulk material. A very mass or bulk material is used for the deformation, and we can give an example: forging, rolling, extrusion. So this all are the bulk massive deformation process. Second process is the sheet metal forming operation. See this is a very small thickness sheet. Okay, and using the sheet, we kept the sheet here. See this is the sheet. Okay, we kept the sheet here, and using a punch we forced the sheet into this die. See this, initially the sheet was straight, then the sheet deformed like this, a cup shaped deformation. Okay, and finally we got a product like this. See this final product. So this is the raw material. This is the raw material. The raw material changes to a cup like a product. Okay, so here we change the sheet into a small thickness. See the thickness, very small thickness. Okay, sheet into a final product. Okay, but here in this bulk deformation, the thickness is very huge. Okay, or in other terms we can say the surface to volume ratio in the formed parts increases considerably under the compressive load in case of bulk deformation. Okay, surface to volume ratio will be increased, but in case of this sheet metal forming operations, see this, the sheet thickness does not affect. Here we can see the thickness, this much is the thickness, and the final product also has similar thickness. Here in the sheet metal operation, just to change the shape of the sheet, there is no change in the thickness of the sheet. Okay, the thickness is not changed, but in this case, in this case the thickness is relatively higher change in the thickness. Thickness is drastically reduced in bulk metal forming operation, but in sheet metal forming operation the thickness will not change. So these are the two important classifications of the sheet metal forming operation. So this is the classification sheet and the bulk deformation process, where we apply the compressive force for the deformation. Significant deformation will be developed. Okay, the significant reduction in the thickness will be developed in the bulk deformation. And before see the difference, we can see a video. This is the bulk deformation process. This one is the bulk deformation. Okay, this is a forging process. See this. It's an upsetting process. Okay, so the initial workpiece was a particular height. We apply a compressive force using a press. Okay, using a press, so that it will reduce the height of the workpiece. And this process is called upsetting process. It's a type of forging process. And this is the punching operations to produce the hole inside of that material. So all this time, these are the see this. This one is the production of the ring production. This is also a bulk deformation process, metal forming process. See this. Then see this one. We these are the forging process. Here in this one is the top die. This one is the top die, and here in the bottom we can see a bottom die. In between the top die and the bottom die, we kept the workpiece, and using this die we apply the compressive force on the workpiece. Okay, and according to the shape of the die, the final material or the raw material changes to the final product. So this is the bulk deformation process. See the size of the workpiece. Okay, it's a very massive workpiece. So this is the bulk deformation process. Okay, all these are the example for the bulk deformation process. So all this type of process are forging operations. We will study all this type of process later. So this is a bulk deformation process. Next we will see the sheet metal operation.
An alloy that's strong yet malleable.
See the thickness of the sheet metal. See the thickness of the sheet metal. It's very low thickness compared to the bulk deformation material, raw material. The thickness is very small.
Machinery uncoils and straightens it. A large blade slices
after uncoiling, it is tightened. Then it is
it to the desired length, producing sheets called blanks. Then it's over to a powerful press.
This is the blank developed from the sheet metal. Okay, and this is go for metal forming operation.
This particular one is a trial press, which offers a better view of the process than the one on the production line. The press forces the blank into a die, giving it the basic shape.
See this, after pressing we can see the basic shape. Okay, in between the two die, we press the sheet metal into a particular shape.
Of 2 car doors. It's a design that's been engineered for both aerodynamics and strength. Back on the production line, the main press is churning out car doors. An automated device with fingers then grips the newly shaped steel and transfers it to a punch cutter. It separates the 2 doors and trims the excess metal from the edges. With the outer door panels now complete, a handler...
See this, the sheet metal is converted to a car door. This is a car door. Okay, so after metal forming, see the time required for metal forming. It's very minimum, maybe 1 minute or 2 minutes. Within minutes, we can cut the we can deform the material into a particular final product. Okay, so that is the importance of this metal forming. So we convert the sheet here in this video. We convert the sheet metal into final product, and here in this is the bulk deformation. We convert the bulk material into a final product. So these are the main 2 classifications. Okay, so here in this bulk deformation, we apply the compressive force. Using die, we apply the compressive force. There will be a significant deformation compared to sheet metal operation. There will be a significant deformation. The thickness reduction will be huge, and this is a massive shape change in this case of bulk deformation. And starting bar shapes includes billets, rectangular bars, etc. We discussed that the billets coming from the continuous casting. Again, these billets are used for, or blooms, slab, different types of ingots can be used for bulk deformation process. And main important characteristics of the bulk deformation process is the surface area to volume is very small. That is very important. Surface area to volume is very small in case of bulk deformation process ingots. But in case of sheet metal process, this is a press working. Another name is called press working operation, because where we are not changing the thickness of the raw material. We just change the shape of the sheets. Okay, so this is a cold working process. Commonly it is a cold working process. We can classify the process into cold working and hot working. The cold working means the process is carried out at a room temperature. That is a cold working process. Use set of punches and dies. Using punches and dies, we can do this process. Okay, and performed on a sheet metal, strips and coils. We see that the sheet metals and strips and coils are used for sheet metal operations. Here, this is the important characteristics. The surface area to the volume is large compared to the bulk deformation process.
In steel, an alloy.
Okay, there are different types of bulk deformation process are there. The main classification are there. This is the forging operations, where we compress the raw material in between 2 dies. And in that also there are different varieties like a closed die forging, coining, hobbing, extrusions, nosing, open die forging, piercing operation, then radial forging, upsetting, precision forging, etc. So we will discuss all this process in your forging topics. Okay, the next one is the rolling operation. In rolling operations, what we do, we use rollers. Okay, using these rollers, we change the raw material shape into according to our requirement. Okay, so we here in this forging operations, we apply the compressive force using dies. Okay, it may be flat die, or according to the requirement, we can make the cavities on the die. And so 2 dies are used for apply the compressive force. But here in this rolling, we use 2 rollers to apply the compressive force. Okay, and in extrusion process, actually we push the material through an opening. So here we have some material. We push the material through this opening, and the final product will have the cross section of the opening. This is the extrusion process. And in deep drawing process, similar to the extrusion process, but in the deep drawing process, the difference is that the raw material actually pulled. Here it is pushing, the pushing force or compressive force is applied here, but it is pulling. Okay, the tensile force is applied on the material to come out through the opening. So that is a drawing operation. So all this forging, rolling, extrusion, drawing are the major important bulk deformation process. And we have sheet metal operations, and basically the sheet metal operations are bending. So bending here, we place a sheet metal and we bend the sheet metal like this. Okay, we use different bending operations are there. The roll bending, break bendings are there. Then surface contouring of sheet metals like bulging, forming, edge forming, contour stretching, forming, etc. So we will discuss all these things in the fourth module. Then we have drawing operations, etc. In the comes under the sheet metal forming operation. Okay, and next one is the forming properties of metals and alloys. So here I think this area we can take in the next lecture. I am stopping up to this slide. So far we discussed about the fundamentals and importance of metal forming operations, and next we will discuss about the properties and we will study some fundamentals of the mechanism solids related to the metal forming in the next lecture. Thank you.